Question number 1 from ISS 2025, paper 1. X follows beta distribution of first kind with alpha greater than 1 and beta greater than 1. What is the mode? So let us write that. Suppose a random variable x follows beta distribution with parameters alpha and beta. Here alpha is greater than 0 and beta is greater than 0. The range of x should be either open interval 0, 1 or x should be closed interval 0, 1. Now, first of all, see what is the expected value of x. The expected value of x is alpha upon alpha plus beta. The expected value of x is alpha upon alpha plus beta. Here alpha is greater than 0 and beta is greater than 0. Now, if we are given this condition alpha greater than 1 and beta greater than 1, then how to write the mode? To write the mode, just write the expression of mean first. Alpha upon alpha plus beta. Now subtract 1 from the numerator and subtract 2 from the denominator. This will be the mode. Here, what is the condition? Condition is that alpha should be greater than 1 and beta should be greater than 1. Now, if we want to write the expression for median, how we can write the median? Just write the expression of mode first. Alpha minus 1 upon alpha plus beta minus 2. Now the condition should be same. Alpha is greater than 1 and beta is greater than. Now divide 1 by 3 and 2 by 3. So this will be the expression of median. How can we understand this? Suppose x follows beta distribution with parameter 2, 3. Here value of alpha is 2 and value of beta is 3. So in this case, the expected value of x should be alpha upon alpha plus beta. So value of alpha is 2 and alpha plus beta. So this will be 2 upon 5. What will be the mode? Now here both alpha and beta are greater than 1. So we can write 2 minus 1 upon 2 plus 3 minus 2. This will be 1 upon 3. Similarly, we can find the value of median. What will be the median? 2 minus 1 by 3 upon 2 plus 3 minus 2 upon 3. So this is how we can find the mean, mode and median in case of beta distribution. So for this question, the value of mode will be alpha minus 1 upon alpha plus beta minus 2. Option A will be correct. Now you may ask that when defining the random variable x, we have written that alpha is greater than 1 and beta is greater than 1. But when we are finding the mode, why we have taken this condition alpha is greater than 1 and beta is greater than 1? Why while defining the median, why we have taken the same condition here? So depending on the values of alpha and beta, the value of mode and median changes. How this happens? Let's see in the next question. So the next question says that for beta distribution of first kind with parameter alpha and beta, consider the following statements. For alpha greater than 1 and beta greater than 1, density has unique mode. Okay, so just before we have seen that the value of mode is alpha minus 1 upon alpha plus beta minus 2 with the condition alpha greater than 1 and beta greater than 1. So if alpha is greater than 1 and beta is greater than 1, then this expression will give us a unique value of mode. So statement first is correct. Now what is the statement second is saying? Statement second is saying that for alpha plus beta equals to 2 such that alpha and beta both are equals to 1, all points on closed interval 0 to 2 are modes. All points on closed interval 0 to 2 are modes. Now we saw in the previous question that when defining the random variable x which follows beta distribution with parameter alpha and beta, the range of x is either open interval 0 to 1 or the range of x is closed interval 0 to 1. Okay, so if we have alpha greater than 1 and beta greater than 1, then we have mode given by this expression. But when we have alpha equals to 1 and beta equals to 1, that means the value of alpha plus beta will be 2 obviously. So there is no problem. But if alpha equals to 1 and beta equals to 1, in that case, all the points in this range, all the points will be modes. All points between 0 to 1 will be modes. But what the question saying? All points in 0 to 2 are modes. But we know the range of x is only between 0 and 1. So because of this range, the second statement is wrong. Okay, so if this statement was that for alpha plus beta equals to 1 such that alpha equal to beta equals to 1, all points in closed interval 0 to 1 are modes, then in that case the statement 2 would have been correct. But because of this range, the statement 2 is incorrect. Now we also read one fact that if alpha is less than 1 or beta is less than 1, if any of 1 is less than 1, in that case mode does not exist. In that case mode does not exist. So we have studied 3 facts here. Let us revise them one by one. Fact 1. If x follows beta distribution with parameter alpha comma beta with alpha greater than 0 and beta greater than 0 with x of range 0 to 1, in that case the value of mode will be unique, like alpha minus 1 upon alpha plus beta minus 2 if alpha is greater than 1 and beta is greater than 1. What is the second fact? Second fact is that if alpha equals to 1 and beta equals to 1, if both are equals to 1, in that case all points in the range of 0 to 1 will be mode. What is the third fact? If any one of alpha or beta are less than 1, in that case mode does not exist. In that case mode does not exist.